Hello students, welcome. On our previous classes, we were dealing with Form 4 Topic 4, that's electrochemistry. So today, we want to proceed to Topic 5, that's the chemistry of metals, and we are going to start Lesson 1. We are going to do extraction of metals. Learners, remember, some metals occur naturally in free and combined states like gold, while others are found combined with other elements like sodium and sodium chloride. So we're saying metals are extracted from an ore. So what's an ore? An ore is a rock which contains the mineral or which contains the element to be extracted. So next, what is a chief ore? We are saying chief ore is an ore from which the metal can be obtained on a commercial scale. So for an ore to be regarded as a chief ore, it has to have a higher percentage composition of the metal or the mineral. Then the next is that ore must contain less impurities so that it only requires less purification. So if it has those two characteristics, that ore can be regarded as a chief ore. So let's go to chief ores of some metals. So here we're having the metals, the chief ore, and also the other ore, because we are told a given metal may have several ores. So we are going to start with sodium metal. The chief ore in the extraction of sodium is called rock salt, that is sodium chloride. Then the other ores from which sodium can be extracted include sodium chloride, NCl, that's the formula of sodium chloride. We're having torona. Torona, remember, is a double salt containing sodium carbonate, sodium hydrogen carbonate, water of crystallization. Then next we're having saltpeter. Saltpeter is also known as sodium nitrate, which its formula is NaNO3. So these are the other ores of sodium, but the chief ore in the extraction of sodium is known as rock salt. So next we are going to go to the second metal, that's aluminum. The chief ore in the extraction of aluminum is called bauxite ore, and bauxite ore is hydrated aluminum oxide. So this is how it is written, the formula of bauxite ore. Then next we are having mica. Mica is potassium aluminum silicate, and it's written K2Al2Si6O6. Then next we are having corundum. Corundum is anhydrous aluminum oxide. So the difference between bauxite and corundum is that corundum ore is anhydrous aluminum oxide, while bauxite ore is hydrated aluminum oxide. Then next we are going to go to zinc metal. The chief ore in the extraction of zinc are two. One is zinc plate, that is zinc 2 sulfide, and the other chief ore can be calamine. So calamine is zinc carbonate. Then the other ore from which zinc can be extracted include zinc oxide, which we can write ZnO as it is chemical formula. Next, we are going to go to iron metal. The chief ore of iron is hematite. Hematite is iron 3 oxide, and the other ores from which iron can be extracted include magnetite. Magnetite is tri-iron tetraoxide. We can have siderite. Siderite is iron 2 carbonate, and we can have pyrite. Pyrite is iron 2 disulfide, which is written FeS2. Then we go to lead metal. The chief ore is galena, which is lead 2 sulfide, written BbS. Then we can have the other ores of lead include cerussite. Cerussite is lead 2 carbonate, and we can have anglesite. Anglesite is lead 2 sulfate. Then lastly, we are going to go to copper. The chief ore in the extraction of copper is copper pyrite. Copper pyrite is written CuFeS2. Then the other ores from which copper can be extracted include malachite. Malachite is basic copper 2 carbonate. We can have copperite, which is copper 1 oxide, and also azurite, which is again basic cobalt-2 carbonate. So learners, in this chapter, we are going to be dealing with 6 metals. So those 6 metals include sodium, aluminum, zinc, iron, lead, and finally copper. So next we are going to go to extraction process, and we are going to start mining of the ore. So we're saying mining is the process of extracting ore from the earth. So we're having types of mining. One is called deep cast mining, and the other one is called open cast mining. So deep cast mining is used to extract ores found deep inside the earth's crust. Then open cast mining, which is also known as quarrying, is used to extract ores found on the surface of the earth. After mining the ore, the second step or the second process, we are supposed to crush the ore. So we are going to go crushing of the ore. So we are saying the ore is ground into fine powder so as to increase the surface area for the extraction of the metal. The third, we are going to go to the concentration of the ore. The aim of concentrating the ore is to remove impurities. So let's go to the methods used to concentrate ores. The first method that we can use to concentrate ores include physical separation, and in physical separation we can have part A, froth flotation. So how is it done? Here we are told the ore is ground into fine powder, then mixed with water containing special oil such as pine oil as a frothing agent. Then we are told froth rich in mineral is formed at the top while impurities sink at the bottom. Then next we are told the froth is skimmed and dried. And we are told this method is used to concentrate copper pyrite, zinc blende, and also galena. So remember, copper pyrite is the chief ore in the extraction of copper, zinc blende is the chief ore in the extraction of zinc, and galena is the chief ore in the extraction of lead. That means copper, zinc, and lead, their chief ore are concentrated using froth flotation method. So the second is gravity and electromagnetic separation, which is also under the physical separations, and we're saying this method is used to concentrate hematite. Remember, hematite is the chief ore in the extraction of iron. Number 2, we can go to chemical separations, and chemical separation include chemical leaching, and we're saying this method involves use of chemicals such as sodium hydroxide to concentrate the ore. And we are told this method is used to concentrate bauxite ore. Remember, bauxite was the chief ore in the extraction of aluminum. So when we want to concentrate bauxite ore, we have to use a chemical separation called chemical leaching, where we are going to use sodium hydroxide to concentrate the ore. After concentrating the ore, the fourth process is we have to do reduction of the ore. And we are saying the method used depend on the position of the metal in the reactivity series. So the method used are 2. Roman A, by using carbon or carbon 2 oxide. So here we are told they are used to reduce less reactive metals such as zinc, lead, iron, and copper. All of these ones are less reactive metals, so therefore they will be reduced or they will undergo reduction using a suitable reducing agent like carbon and carbon 2 oxide. Number B, we are told by using electrolysis method or electrolytic process. So we are saying it's used for reactive metals such as sodium, potassium, calcium, magnesium, and also aluminum. Remember, these elements are more reactive elements, so they will be reduced by a method called electrolysis or electrolytic method. So after that, we are going to go to the fifth process, that is purification of the metals. And we are saying metals obtained from the reduction process usually contain a number of impurities. It is therefore often necessary to purify them before they can be used. This purification process is also known as refining. So we're saying the methods used for refining vary widely depending on the chemical properties of the metals and those of the impurities. These methods include the following. Number one, we're having electrolysis. So that means we can purify some metals by the use of electrolysis, which is also known as electro-refining method. We are saying metals such as lead, copper, and silver can be refined by electrolysis method or electro-refining method. How is it done? How is electrolysis done? We are told a block of the impure metal is made the anode of an electrolytic cell, and we are told the cathode is a thin sheet of the pure metal, and the electrolyte is a solution of a salt of the metal. What do we mean by this? For example, if we want to purify copper using electrolysis method, what we are supposed to do is that we are supposed to take a block of the impure copper metal, which we are going to make the anode of an electrolytic cell, and the cathode will be made up of a thin sheet of the pure copper metal, and the electrolyte is a solution of copper 2 sulfate or copper 2 nitrate of the copper. So next, the second method of refining metals is oxidation, and we are saying this method is used in situations where the impurities react more readily with oxygen than the metal interest. And we are saying how is it done? The crude metal is heated until it melts, and a ballast of air, that's oxygen, is blown through the molten metal. Oxygen in the air oxidizes the impurities into compounds which are less denser than the molten metal, hence float on the surface of the molten metal where they are skimmed off. So the third method of refining metals is distillation method. When we're saying this method is used in metals that have low melting point, such as zinc and also mercury. How is it done? We're saying the crude metal is boiled in a retort flask, and this vapor is collected and condensed in another container. The impurities, most of which have higher boiling points, are left in the retort flask. And here we can use zinc to refine by distillation method. Learners, that's the end of our class today. Thank you for watching.